Welcome to Miss Lam's Math World. Today we are going to discuss the trigonometry past paper questions. Please turn to page 4.12. Now, let's look at part A of 1999. So now we are going to have a look on part A. So we are going to prove by mathematical induction that this statement is true. So to save time, we will only discuss for the case in proving n is equal to k plus 1, assuming that pk is true. That is cosine theta plus cosine 3 theta plus cosine 5 theta plus dot 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 plus cosine 2k minus 1 theta equals to sine 2k theta divided by 2 sine theta. So we will consider for the case of n is equal to k plus 1, right? That means that pk plus 1. So left hand side, it will keep equals to cosine theta plus cosine 3 theta plus cosine 5 theta and so on. So this is the part of the statement for n is equal to k, and then for the new one, you will have cosine 2 times k plus 1 and then minus 1 theta. Alright, so it is not difficult to see that this one will be equals to sine 2k theta divided by 2 sine theta by mathematical induction. So sine 2k theta divided by 2 sine theta plus cosine. So let's calculate 2k plus 2 minus 1. That means cosine 2k plus 1 theta by mathematical induction. So I think it is not difficult at this moment, but now the difficult part comes because the question will require us to find the right hand side equals to sine bracket 2 times k plus 1 theta divided by 2 sine theta. And then it is not easy to read how to change from these two objects into this one. But you can see that we will only have one term here, and then that means we are going to simplify something. So that means we have to do it like this. That means take the common denominator. Alright, so this is the key point number 1. Common LCM. So after point number 1, so you will need to think on how to simplify these two terms, right? So this is one term, this is a product. So if you got a product, then we need to change them. That means we split it into two different parts. That means we are going to use the product to sum formula. Use the product of sum formula of sine theta cosine 2k plus 1 theta. Product to sum. So the first part, of course, it is still the same, right? And just copy. And then this part, still 2 sine theta. And then when we use this, that means for the product to sum formula, then we use the pattern. Ready? So it is sine cosine, the first case, right? Sine A cosine B. Sine cosine cosine sine cosine cosine sine sine, right? Okay, and then we simplify. 2 times 1 over 2, and then Of course, you can cancel out the 2 and 1/2 in one step. Okay, all right, sine theta plus 2k theta plus theta. That means it's like this, and then plus sine theta minus 2k theta minus theta. Okay, and then we simplify. And we'll get sine 2k plus 2 theta. So 2 times k plus 1 theta. Wow, so you see, we are very close to the answer. So the answer is supposed to be like this. So many guess, what will happen? We already got this one. That means this one we are going to cancel. So let's see if it is true. So right now, we continue to simplify. So it means plus sine negative 2k theta. So this one, it is quadrant 4, right? Quadrant 4. Quadrant 4, this one. So point number 3. So when we have a negative, we need to check quadrant and simplify. So for this one, let me put it away. Yes. Remember, we have to check quadrant. CAST. As a result, this will become minus sine 2k theta because it's quadrant 4. And lastly, we will get sine 2 times k plus 1 theta divided by 2 sine theta. That means this is for our right hand side. Okay. So this is the core of solving this kind of mathematical induction. So it is a very, very common question for proving mathematical induction together with trigonometry. Okay, so let's got the summary. Point number 1. Whenever you want to simplify, you have to check what does the answer looks like. Okay, so if the answer give you something like this, and then we have so many terms here, so we try to split it by using the product to sum formula. Product to sum formula. Of course, you see that this one, you got nothing special, you have common LCM. Okay, so step 1, common LCM. Step 2, use a product to sum formula. Sometimes a question may require you to do sum to product again. But anyway, at least you will need to use it once for this part, product to sum formula. And then if the sign is not really nice to cancel, then you can use the CAST to help you to simplify. And you will get the result. So this is for part A. So let's apply the results of A with the substitution required by the question to simplify this one, to show this one. So when we do so, we can actually just substitute directly. What does it mean? So we check sine 3x, 3x, and 5x, okay? So we don't need to worry about it because the most important point is to first substitute and see what it will happen. And we have 5 theta and 5x, and of course, we will change the sine to cosine by using some method. Okay, so when a is equal to 3, then what you will get? You will get cosine theta plus cosine 3 theta plus cosine 5 theta. That means we start from the way we got it from part A. So left hand side is done. So for right hand side, so sine 2 times 3 equals to 6 theta divided by 2 sine theta. And then, wow, the question is actually not really the same as what we get right now. But don't worry, it says we substitute theta to be pi over 2 minus x. Right? So we have used A, put it tick. And then we are going to substitute. So substitute. Pi over 2 minus x equals to cosine pi over 2 minus x plus cosine, 5 pi over 2 minus x equals to sine 6 times pi over 2 minus x divided by 2 sine pi over 2 minus x. So we need to start how to arrive the result. So let's try from the easiest one. Because normally, whenever we got the question like this, it is not that easy, right? So the first step is to select the things which are easiest to do. So these two are the easiest. Because we have sine 90 degrees minus x equals to cosine x, right? Remember, we change it to radian. So this one. So after we change it to radian, then we will get cosine x. Great! You see, they are the same. So right now we do it similarly. Then cosine change to sine x. Wow, then that means we are going to do it similarly for cosine 3 times this guy and cosine 5 times this guy. But unfortunately, we can't just do it like this because it is 3 multiplied by a number. So what should we do? So we should multiply 3 inside first because we want to simplify by using identity for the CAST. And then this one also multiply. We also multiply the inside. So you got this one, and also we simplify. 3 pi minus 6x. Okay, so you can imagine you get something like this. That means for this one, for example, you get something like cosine 3 pi over 2 minus a, something like that. Okay, so we also use the CAST. So this time it is quadrant 3 and type 2. Okay, quadrant 3 negative. So you get quadrant 3 negative, and then type 2 cosine change to sine. Because 3 pi over 2 is 270 degrees. This one is type 2. Okay, so cosine change to sine, and then the negative belongs to the original trigonometric ratio. Original means cosine. Cosine quadrant 3 is negative. So we can simplify one by one. So right now we get sine x and then minus sine 3x. And do it similarly. So this time 5 pi over 2. 5 pi over 2, you can simplify and you get it is this pi over 2 because you can minus 2 pi. Okay, so this one is a type of a quadrant 1 identity, quadrant 1. Because you can change it to pi over 2 minus 5x. Okay, minus 2 pi, and then you can simplify. So quadrant 1. So cosine, change to pi, sine to sine 5x. And then this one. So let's see. So 3 pi, again, it is too much, and then we can change it to pi. Okay. Alright, again, it's too much. So it is 3 pi minus 6x equals to sine 3 pi minus 2 pi becomes pi. So this time it is quadrant 2. So for quadrant 2, that means it is positive for sign. And right now, you get the answer. Okay. So if you can't understand this one, so let me write one more step for you. So if you get 5 pi over 2 minus 5x, so minus 2 pi. Okay, so minus 2 pi, so this one, minus 2 pi. So you get this one to be quadrant 1. So that's why this one is positive, becomes a sine 5x, okay? So this is quadrant 3. So this one is quadrant 1. All right, so we have completed the whole question of this long question. All right, so I hope you will get a better understanding to solve this kind of questions, okay? MI for part A, and then part B, try to use the substitution carefully and with the correct kind of quadrants. And finally, check the answer one by one to see if your guess is correct. So that's the end of Miss Lam's lesson. See you next time. Bye-bye.